Well, hi, good morning, and thank you so much for joining me here in my shop. Today is September 14th. Very cold. Yeah, I can actually say cold here. It was 9 degrees when I got up this morning. Outside, not 9 degrees in my house. So, what to do next now? All the rough stuff is done. I think the next thing we can do is avail ourselves of the information on the schematic that gives pin voltages for each of the vacuum tubes in here. So I think that might be a good idea. Run around, measure these voltages, and see that they're correct, or close anyway, close enough. And then after that would be maybe tube testing, and then maybe after that alignment. And then maybe after that it's a wave goodbye. Oh yeah, my injured hand. little tiny wound. Did a lot of bleeding yesterday with that. Okay, so voltage readings. I think the meter I want to use, which I'm just remembering where I put it here. I'm going to use this fine guy here. So this has a very high input impedance. It has an amplifier inside it. It's transistorized. It's not a vacuum tube voltmeter. It's a transistor voltmeter. Do they actually have a name for it? It's called the Caution Observe Safety Rules. It's the Triplet Model 64 solid state VO vacuum tube ohm meter, maybe micro power it says. So that's what I'm going to use. And I'm sure all these voltages are read to B minus. A little bit. I got to change the wires on this meter. That's a little bit of a problem there. But for now, I'm gonna take the risk. Not much risk. So what we're gonna do is we're gonna put the negative. We're gonna put it right on here, which is a B minus point. Okay. And I should be able to poke along and read the meter and compare to the table. Okay, maybe I'll put that up on the screen here before we get going, and that'll make it easier. Okay, got the chart on the screen there. Oh, I guess we better turn on the radio here. Of course, we're going to want to do this with the proper AC voltage supplied. $117 is the usual North American number that's quoted. And that's probably going to go down a wee bit. 115. There we are. There it goes down just a wee bit. Is that because of this? No. No. Okay. Let's look at the diagram. Let's see. First tube we can do. How's the diagram oriented? So the diagram has to go this way. Grab it. Go this way with it. So this bottom one over here is this tube right here. So we'll start there. Start there. Pin number 1. So they show the position of the pin markers. Let me do it with the mouse here. They show the position of the key right here. I don't have to compete with that. Right here. So it's pointing at the corner of the radio away from the tubes. Here the key. Yep, pointing at the corner of the radio away from the tubes. Great. Now I should probably have the diagram turned this way because knowing the way I operate, let's get on pin number 1. That's all we got to do right now. Actually, the voltage is only indicated on really one pin, pin number 6. 52 volts on pin number 6. Let's try it a bit. Just watching the meter here. Let's just short it out. There we are, right down to 0. Okay. And we're set for, so an upscale reading is a positive voltage. So I want to go to pin number 6. So we can go 8, 7, 6. This would be 6. Ooh. 52 volts. So that's 57 on here. 52, 57. Right at the bottom of this table it says, we should read everything on this table actually, socket voltage tolerance 10%. So these are bottom views. Measure the voltages to B minus. Voltages in this case have been measured with a 20,000 ohm per voltmeter. That's a good voltmeter. But for DC, but for AC, it's just 1,000 ohms per volt. So you might get a higher reading with a better meter on AC, but we probably won't measure the AC voltages. WJ denotes a wiring junction, so that's a terminal that's not used. Well, where does that appear in here? I don't see WJ written anywhere. NC, no connection. Again, I don't see it written here. Number 6, what? Blank. If it's blank, it's an AC voltage. I don't know what they're saying here. It doesn't match this stuff at all. Socket voltage. Oh yeah, socket voltage. Okay, so maybe we shouldn't have read that stuff. Back to what we're doing. This tube, we found 57 volts here. That's fine. We'll move on. Let's move on. Next tube, 86 and 95 volts. So go 1, 2. Pin number 2. Pin number 2 on the next tube over. This tube here. Number 2. Where's my little flashlight? Here it is. 1, 2. Here's pin number 2. Pin number 2 is giving us almost 100 volts, 90 volts, 91 volts. Pin number 2 is supposed to be 86 volts, so everything's a little bit high. That's fine. Then we've got 110. Oh, that was supposed to be 86 volts AC. Oh, whoa, 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 whoa. How did I manage that? How did I manage that? Taking the DC voltage. Okay, not sure what to think of that. A lot of DC meters will respond with the AC voltage. I wouldn't think this one would, but it appears to have. Or did I do something wrong? Yeah, I probably did something wrong. Pin number 3 is the plate, 110 volts. And 4 is the screen. Let's try this again. 1, 2, 3. This is 3. That's supposedly an AC voltage. This is 4. 90 volts. And this is I gotta be doing something wrong here. Or is this table not going to apply? How can it not apply? It's the same tube, 50L6. And that's my finger doing that, by the way. Do I have this set right? It's a new meter to me. Maybe I've done something dumb. I have done something dumb. There. Okay, now. Oh my God, I had the meter set to AC and I'm taking readings and going thumbs up and my God. See, this is why I don't work in the medical industry, People would die. There's no doubt about it. Okay, let's go back. We'll start over again. Plate voltage pin 6 on the first tube. Plate voltage pin 6. $57 volts. I think what I would see there. 57 volts, and it's supposed to be 52. Perfect. Okay. I don't believe it. I'm gonna, oh well. Yes, I have to believe it. Now we'll go to the next one here, which is going to be, this time will be pin 2, 3, and 4. 2 is an AC, 3 and 4. 3 and 4, 110 and 95. 3 and 4. 3 and 4. 1, 2, 3. I've done something really, I don't know what I was doing there. So it's just over 100 volts, and it should be just over 100 volts. And the next one should be just under 100 volts. And there it is, just under. Excellent. Okay, that's correct. Next tube. I think I know what I'm doing now. Next tube, we want to go all the way around to pins 8 and 7. 8 is 115, 7 is 86. 8, right over. Nobody home here? So that's 8, that's pin 7. And pin 7 should have 86. Oh, AC, volts AC. Duh. Don't worry about that. We don't worry about that right now. It's a heater. Maybe we'll do those two tests too. So anyway, the DC was fine. Okay, I think I almost know what I'm doing now. Next one over. Okay, so 2 pins, 6 and 8, 95 and 88. 6 and 8, 95 and 88. Okay, pin number 6. 95, it's about 90, and pin number 8, about 90, about the same voltage on those two. So it'll be 95 and 88. I think it's okay. But I'm really looking for is a case where there's no voltage, where the voltage is way off. Such is not the case so far. So last tube, pins 3 and 4. Looks like 88 and 95. Pins 3 and 4. Three and 4, 88 and 95. 1, 2, 3. 89 and 4. They're both reading the same. 89 volts or so, and it's supposed to be 88 and 95. So sounds like the maybe the screen voltage is a bit high. Well, that's good. That's pretty good. Now, should we try the AC side of things? So what's going on with the AC test is you're reading the voltage at either side of the heater, or either heater or terminal, through a series. There's a series of tubes here. So you're going to start at, depends on how they start, depends on where we start. Start at one end, you get the full line voltage, and then work down to nothingness. I'm not going to worry about it. I'm not going to worry about it. Okay, so that's it. Voltages are okay. My ability to test them, not so good. But there we are. So next thing, either alignment or tube testing. Why would I bother testing the tubes here in this radio? Let's hold off on that. What I'm going to do is I'm going to align the radio, then we'll play it, see how well it's working, and then we can think about tube testing, whether it's worth doing or not. Okay, we'll put the power back on. And okay, I gotta get a couple things set up here and we will start. Okay, the instructions say to use a 200 picofarad capacitor as a to insert it in the signal line coming from the signal generator over here. That indicates they are anticipating a technician like me attaching the output of the signal generator right into the radio circuits in some fashion, but I'm not going to do that. Instead, I'm going to use this very simple coil, just 3 turns of a heavy wire here, and it's hooked up to the signal generator. Whoops, I just tapped the microphone there. And then I've just got it positioned right up against the antenna to the radio. And I'd rather try to push a signal into the radio that way, at least initially, and see if we can get away with it. I'm going to have the voltmeter connected to read the AVC voltage, and I'll use that to judge whether I'm getting the radio better tuned or not. First thing we're doing is the IF. So I have the signal generator running at 455, which is what it showed on the information for the radio. So we're ready to go. So we're going to turn on the radio here. Give it a minute or two to warm up, and then we want to find out if attaching this meter. If attaching this meter. Does attaching the meter make a difference in the operation of the radio? So you're listening to the radio now. There we go. Slightest change, but not enough to be concerned about, I'm pretty sure. There we go. Now the instructions are during this to open the capacitor all the way. Try to get a quiet spot. ABC meter's connected. Oh, it's not turned on. We're on DC this time. It's a negative voltage. Let's see. The tuner should go up and down. Yes, it does. Good. Let's get it where it goes down. Don't go much lower than that right there. Okay. Now, why can't I hear the signal generator? Must not be enough juice coming over. It doesn't matter where the radio is tuned at this point. You should hear this guy. Let's give it more something there now. Okay, let's give it a wow. So we're barely hearing it. That's either because my method here of using the loop is not effective, or the alignment is way off. Let's go for the alignment here. We don't want this moving while I'm doing this. Do something more. Yeah, sure. Slamming this up against the antenna is going to affect the antenna a bit. I'm not worried about that. Not during the IF tuning. Let's start with the second IF. I like to spit on things before I start. We have full voltage, 115 volts. Okay, make that meter go way up. That's the plan here. There we go. Oh my gosh. Did I not turn this one last time? Holy smokes. That does not want to turn. Screwdriver with a bigger handle here. That's not good. There it goes. Oh my gosh. Wasn't that something? Somebody cranked this right down. Maybe they thought it was loose and it needed to be cranked down. Wow, well this is going to make a big difference. Well, maybe not. If they were all tuned off, but tuned to the same spot, like maybe 450 or 445, the radio would still operate. How are you getting this one? It's way up. Is this one stuck too? No. This one's on. This one was right. Huh. Okay, here we go on this one. Oh yeah, look at that. Now there's a bit of a noise signal there, so I've got my oscillator signal and there's a noise signal right next to it. And as I tune the IF, I can select one or the other. The noise signal can be stronger than the signal coming from the signal generator. It can be. I can accidentally align this on the noise based on a higher meter rating. Okay, last screw. How bad can you be? Just get all it's got here. Use 1,000 hertz. Okay, let's go through these once again. Okay, starting down here. The sticky guy. There he is. Sticky guy's brother. I got about a needle width more out of it. First IF. Yeah, you might notice I'm using a metal screwdriver. You might think, oh no, never use that. Well, you want to make sure it's not affecting things. The metalness. I'd say that's peaked up. Okay, now we can just take this away. Did that make any difference in the operation of this radio? Careful now, we got wires hanging out. That's going to be 680, which we had trouble hearing before. This is probably not the sports channel. Okay, let's go further. Yeah, that was the sports channel. Just can't fight that noise out. Okay, but what I would say is, as hard as that is to listen to, definitely performance improvement from that. Now the last thing is just two more adjustments to make. C and D. C is bound to be, oh it says right on it, signal generator output to antenna. Oh that's right, we had to put this back here. So you can hear the tone from the IF signal again. There's a heterodyne there because of the difference in frequencies. There's a heterodyne there. Don't go any further. Just say that. 1400 is where we need to go now. 1400. 1400. Loads of power. Okay. $1,400. Wait a minute, I don't have the dial face on here. Turn it down a bit. So the challenge now is the radio dial. I remember right, it fell right out of the radio here. Take a look at this ugly beast here. Somebody's glued it. Looks like it's been glued more than once. And the glue is, as you can see, it didn't work. It's got a scratch right across the word Crosely, probably from the tip of the antenna here. Tip of the pointer, rather. Maybe not. No, it couldn't be the tip of the pointer. How am I supposed to do this now? How do I know this isn't here or here? You can always just center it right up on this bracket and look through it. If I were to do that. So how far left or right could it be? There's a light bulb in the way and there's two spring attachments here. Why exactly these are here, I don't know. This one's bent over. I can imagine that they're supposed to push the radio in until these contact the back of this. Somewhere. And sometimes there's a pointer marker on here, so you would tune the capacitor all the way one way, and then the pointer should be lined up with something. Could be an extra little dot. I don't see such a thing here. Or it could be a particular point, like the very end of the, it could be anything that they might have set up. There's some lines here. Hold this right. You can see the lines here. You see up above there's a line going along all the way, and then it ends right under the 16 or the 160 there. That's because it's rubbed off. I'm pretty sure things are rubbed off in here. No indication as to where the pointer should be at maximum. No instructions I saw. So if we did move it all the way, okay, so let's see, it goes, it's supposed to, go basically from 160, so we would expect, wow, it's way past 1600. Okay, let's go this way. Okay, capacitor is closed. Okay, just past 550, so it'll be around 540. I think the pointer is too far to the left because it's running way up into here and just barely passing the 55. How loose is this pointer? Let's take a look now. Maybe it's clamped right down on that string. What can I do here? Okay, ignore what you're going to see. Oh, that's not a tall one. Yeah, that's good. Okay, that's good. Is the autofocus on? I think it is. Can you please autofocus? There we go. Sort of. Okay, looking at how the string is in there. Looks very loose to me. See the metal tangs, it could be squeezed down on the string pretty hard. They don't seem to be. Sorry it went out of focus again, but and then the lower one is actually sliding. That's that lower string is just supposed to keep the pointer at the right elevation, which it's not doing. It's become loose. So I think we can move that on the string. Let's see. Let's see if that's really what we can do. Okay. Now, there isn't a lot of room to go this way either. So it's about half an inch here, or about a centimeter. It's a little closer over here. I'll probably wear the string out while I'm doing this. Okay, can we move it? So to move it, that beeping is once again my coffee alarm going off. To move it, we want to freeze the string on the side or in the direction we're going to move it. So you might think you should hold it here, push that way. No, you should actually hold it here. It's counterintuitive. What's going on there? Doesn't want to move. Okay, so it does not want to move. So we're going to leave it alone. We're going to say, okay, it is where it is. It's probably been there its entire life. The guys at the factory did the right thing and it's still okay. So that's 1400. It's picking up 1400. If I just center this, it's at 1500. Awkward situation. Can I just put it like that? I can. I can just put it like that. Pretty sure it's going to fall off as soon as I... So what we want to do is we want to get 1400 coming in at 1400. So let's dial it to 1400. Okay, so now we're going to make an adjustment here. See, on the capacitor here, the smaller side is the oscillator, and that's the first thing we're going to adjust. The oscillator will change the position on the where the radio is receiving. So that's what I'm going to be doing. And then I'm going to tune the radio at the same time. So first of all, which way? Oh my gosh, that's really stiff. Let me get a bigger screwdriver here. Okay, this will do it. There we go. Right past. Tune. Okay, tune it right on 1400. Make sure this is centered now. I'm guessing this is the correct position for the dial. Can't be too far off because these brackets are right out at the limits. Okay, so we'll dial in 1400 right on. Now we'll watch the meter. There's some kind of interference signal right at 1400 also. There we are. So we've done step 1. We've done the C. Now we want to do the D. Also at 1400, and D is just the other trimmer. It's kind of an antenna tuner, I think you could say. Just crank down tight. Shows a peak. So somebody may have come along and tightened up those loose screws they found. That may have happened. There we are. Now, I'm going to find out just how well this radio actually works. Still with its original tubes. this off so it's not interfering. Down. Way up at the wrong end. The first station we could pick up potentially is about 840 or 860, I can't remember now. There's a 1010. I hear it. Darn interference. Just, I don't know if you could hear it, but I can hear a French voice. Right at 860. Perfect. .680, no, 710 is possible. 680. Right there. .640. .590. Just got that interference right on top of it. So the adjustment of the capacitor is done at the high frequency end. I'm going to adjust it again because most of the, if this radio is going to be used by somebody, they're going to, around here, somebody in this area, around Toronto, they're going to end up at the low end of the band. That's where the stations are. So I'm going to adjust the antenna here, see if I can get a little more out of it at the low end. Probably not. Remembering the position. No. Okay, back where it was. Well, the only thing that's left now is to test the vacuum tubes in the radio and see what happens when I do that. Sounds like an interesting idea. I will do that next. Tube testing. Okay, here we go with the first tube, 50L6. Let's just double check things. 50L6. It's in the dark here. I'm working in the dark. It's really dark for me because it's the only way I can supply lighting that you can see the dial. If I turn the lights up any higher, this will just go white. So that's why I'm working in the dark. 47 volts. 8 signal level. 18H, 18, yeah, 18H for the bias, 07345, 07345, I've already set this up, I'm double checking here, 0610, 0610, 43, plate is on C, there we go. I start with the output tube. This is the this is the one that won't affect the radio's performance, although it could certainly affect the radio's volume. That's for sure. Give it a moment here to warm up. Okay, we'll check for shorts. Just, I think if there was a short, we would know it already. Okay, so this tube's reject point is 1030. So there's 1000 right there, and it's right there. So back in the day, I'd be trying to sell a new tube to this person. but we're not back in the day. So this guy passes. It's working good enough. We've heard the radio operate, so we can't be too worried. And that reminds me now, a kind viewer sent me an interesting email talking about the 12 SA7 tube that's in here. Trying to help out with understanding why some of the tests I did before went the way they went when I was fooling around with the capacitors. So I'm checking this to 35 Z5, correct? Okay, so this will be the rectifier tube. So just hang on, I'm going to do this quickly. Additional lighting for me. 35 Z5, 35 Z5, 35 Z5, there it is. So that's a 25 Jim, 35, 35. Hard to see here, 35 Z5, there we are. Okay, 35 volts. There. Turn back on there. Don't care about this, it's a rectifier. We don't care about bias, it's a rectifier. 35 Z5 07003 07003 0610 0610 23. Okay. E. There we go. Now again, I mean, if this tube was really bad, the radio wouldn't have operated at all. Like if the tube was dead. Actually, if let's say the heater had gone open in this tube, none of the tubes would have heated in this radio because they're all in series. They all use the same current, even though some of them have different voltage drops. It's the same current. Okay, looking for shorts just in case. Rectifiers are notorious for getting shorts, but again, if it had happened, we would have found out the hard way a long time ago. So we're going to push the rectifier diode switch. The rectifier needs to come up to this area. I don't know if you can see that or not, but just below my thumb, there's a little indicating area down here. Rectifier's okay. Is it okay? Ooh, it's okay. That's the end of that. Okay, I'll get the next tube ready here. Okay, ready to go now. Let's see here. 12 SK7. So we set the voltage setting to 13. Why not 12? 2, 10 L, and then the numbers are 17253, 17253, 3. Mistake there? I guess, is it a 1? Bring on some extra light here. It's a 1. 2, 5, 1. Yeah, it's definitely a 1. That's correct. And then 4630. 4630. Okay. 44. And C. Okay, got it right. It's my laundry room light I'm turning on there. It'll turn itself off in a moment. Actually, it looks pretty good. But I can't keep it on unless I go in there and spend time in there. Okay. Give it another moment to warm up. Short check, same story as the other tubes. No shorts. This tube, 12SK7, should come up to 1520. So 1500 is right straight up. So just beyond here or above. Oh, that's great. Okay, this is a great tube. That's a good one. Let's rush that back into the radio, and I'll get the next tube ready. Okay, next tube is the 12 SQ7. That's really a two function tube, just under one shell. So there's two tests for the two different functions. The first test is the triode that's in here, triode amplifier. So 13, signal level 1. Turn on the light. 18, L, good. 25100, 25100, 3760, 3760, 37, F. Okay, so ready for a test. So again, this won't really affect the receptive performance of the radio, not this part of the tube. It's the audio amplifier, so it could affect the volume, could affect distortion, things like that, the actual sound. But the radio waves, this part of the tube, no. Okay, checking for shorts again. Always check for shorts. Nothing there. This tube will pass at 760. 760 is right around where my finger is there. Whoa! Okay, so this one's failing the test. Now, when I get a tube that comes up low, like this is probably 80% of the reject point, so it's quite a ways below. So what I do is I do a sensitivity study on the settings, the two variable settings here. So if they're a little out, is it enough to make the tube look good? Well, it's tough. This is supposed to be 37. And then this one, the bias. Well, the two in combination, if these are a little out, if they're not calibrated properly, and they may not be. But this, I think, is coming out as a weak tube. Now we'll do the other test. It's a diode test. So I'll reset the machine. We don't care about this anymore. We don't care about that. So 2013 P. 2013 P. 0760. 0760. 48. A. Very important to get this correct. Again, 12SQ7, diode side, 2013 P, 2013 P, and 0760, 0760. Good. 48. A. There we go. The diode test is made by throwing this switch, it says right on it, diodes. And all they got to do is come up past this little marker here, which again you might have trouble seeing, but just past the end of my finger, this thumbs up. We'll look for shorts again. No. This is the button. Does it get up to here? Yes, it does. Now there's two diodes in here, so to test the other diode, we flip this to P2 and do the test again. Much higher. Much higher. But they are both in the good range. So this tube is there, so a little weak on the audio amplifier. Ow. Another hole in me today. Oh, it's trying to go right through. Okay. Would it be worth changing this tube? Probably not, in my opinion. The radio's producing enough volume. I think not. So now we're down to the 12 SA7, which I'm going to get out of there, and then we're going to talk about the what someone informed me of. Interesting fact. Okay, let's take a look in the book for 12 SA7. Here it is here. Now let's see, there's two diagrams here. One is the metal type and the other is the glass type. The glass type has nothing hooked up to pin number 1. So on this type, if you look right at 1, there's a dot. Right, and that indicates a connection to the outside metal shield on the metal tube. And then look inside, it goes up to the suppressor grid. So that's a little odd. Pin 1. The suppressor grid is tied essentially internally to the metal shield. And in the radio, it's also connected through the capacitors and to the other metal shields and stuff like that. If you look at this, this is what I'm used to. If you look at this one, you look at the suppressor grid. It goes over to pin 6, and then there's an internal connection down to the cathode. Well, that's all I've ever heard of. Sometimes it's internal, sometimes it's not. But I do know that clever engineers will do stuff with the suppressor grid once in a while in unusual circuit arrangements typically found in test equipment and non-radio circuits, things that we aren't normally looking at. But occasionally engineers will utilize these grids differently than they might be intended. Kind of like an off-label use, if you like. So going back to this one, well, this really raises some interesting questions. Like, why? That's the first question. Why? Why would they do that? So maybe you have the answer. Throw it in the comments if you wish. And or conjecture. Conjecture is fun. That makes us think. And there we are. So there's something unusual about this, and it probably explains why a particular capacitor, when I went without it, I thought this won't make much difference, and ended up making a big difference. It may have something to do with this arrangement here. If you don't drain this out, the suppressor's not connected. Not connected to the cathode or anything. So what would happen? Gee, I don't know. But there we are. Something unusual about the SA7, at least the 12 SA7 metal tube. Something to watch out for down the road. Okay, let's go back here. You know what? No, I've got to change cameras again here. Let's switch to the other camera. Okay. Now, have I got this all set up? No, I didn't set this up yet. Okay, I'll stop the video and I'll get this set up. Okay, we're ready now. Let's just double check here. 12 SA7. So 13.2 9L for low, 27.345 27345 1650 1650 45 C. We're good. So this is the last tube. This is if there's a tube problem, it's got to be this tube. Tube problem affecting the radio reception. It would have to be this tube. The IF amplifier tube was quite strong. That's where a lot of the goodness comes in the radio, is in the IF and the IF amplifier. So this guy's job is to mix together the local oscillator and the signal that's coming in on the antenna. Mix them together and come up with a new signal to send on into the IF. Okay, it's got to be warmed up. Any shorts? No. No shorts. This tube should come up to 1100. 1100. So 1100 is just above, just here. Wow! Holy smokes! It's off scale. It's a super tube. That's quite a reading. That's a little unexpected. I kind of thought, yeah, this will be weak. Let's just double check a few things here, just in case. Signal 2, 9L. Yeah, 45. Okay, I'll do a little sensitivity study here. Ooh, see, that really goes. That really ranges. It was supposed to be 40. What was it? It's supposed to be 45? 45. Okay, and what about the other? What about the bias control? Not much difference there, so but this one quite sensitive here. So maybe the tube tester's being kind to this tube, but even if it is, this tube's not the cause of the problem. None of the tubes can be held responsible weak reception or something like that. So the result is we've reached the end of the road here with this radio, except for the problems of its cabinet and this horrifying thing here. You know, like with all these things, the writing's on the back, but I can see bits and pieces are gone. Looks like the top of the 140 is gone. Part of the one here is gone. That tells me that you can lift the paint off the back here probably fairly easily. You don't want that to happen. So cleaning this, a bit of a precision task. Just laying it down like this and running it around, that might be enough. I've had one case where it didn't matter how lightly you touched the back of the dial, the paint came off. There was literally nothing. It was like dust sitting on it. Probably if you whacked it hard enough, some of it would come off. So these can be extremely fragile. Ruin this, ruin the radio. But it is possible to get new plates from a company called Radio Days. D-A-Z-E is Radio Days. And I've done business with them quite a few times. I'm not trying to promote them here, but I am, because they have, every time I've bought a product from them, it's been beautiful, it's been perfect. And in fact, in just a day or two when I'm done with this radio, maybe tomorrow, I'll be showing you one of those plates that I just acquired from them for another radio that's been waiting for about 6 weeks for the plate to come, and it has. So probably get a new one of these if you wanted to. I don't think I want to, though. Okay, that's it. I think that's it. I can't think of anything more to do here to help this guy along. So thanks a lot for watching the series. Yeah, tomorrow I'll probably have the other radio back in here and we'll start looking at how to put the plate on. It's not simple. It doesn't look simple anyway. And there we go. As for the cabinet for this guy, where is the cabinet? The cabinet is wandered off. Here it is. Oh, right, it's this one. Right, it's this cabinet here. So, did somebody paint this blue? Or was it blue from the start? What's all this stuff? Almost looks like somebody spilled paint on it. It's really kind of odd. So I'm looking for cracks and fractures, especially in the corners. So it's taking a little bit of a crack right here. Crack is not extended. That's probably a drop. Boom. That's probably what happened there. And you can see the, it's a little hard to see here because of the lighting, but you can see inside where the glass goes. What a mess in there. Jeepers creepers. And here's the handle. I think I've done another one. I think I've done one of these radios with this crazy handle arrangement. And it's not a home built thing. It's actually you know, you have to think that didn't come from the manufacturer. Surely to goodness he wouldn't. I mean, why do you even need a handle for a little radio like this? Pick it up. I don't know. Okay. There we go. I'm done. A bit of a slow finish. Thanks a lot again for watching the series, and thanks very much if you're clicking the like button. Thank you very much. And I hope you enjoy your day. I'm off to enjoy mine. It's a beautiful sunny day here. It's going to be sunny all day, today, tomorrow, I think even the next day. But cool, very cool. So fantastic. Thanks a lot. See ya.